Hello, welcome to my presentation for Semantic Segmentation for Unstructured Terrain Traversability. So my motivation. A robot needs to understand their surroundings to plan, and semantic segmentation provides a great way of doing that. So the main problem is that a lot of segmentation models that exist are not designed for unstructured terrain traversal, but are more generalists. Fine-tuned models perform better than generic ones, so I want to make my own fine-tuned one. For my PhD, I'd like to design a robot capable of traversing off-road environments. And to do so, I'd like to use a semantic segmentation model as a pre-processing step for my path planner. So there's lots of different use cases, for instance, pipeline inspection, search and rescue, and automated agriculture that have very varying environments. So my objectives. I'd like it to be reliable, compute light, and repeatable. So what that means is that I'd like to accurately determine whether or not terrain is traversable or not traversable, and I'd like to find obstacles, and this can be measured using the intersection over union metric. Compute light means that I'd like it to run on an onboard system, so that means I'd want it to little VRAM as possible. And I'd like it to be fast, so have a high inference speed. Repeatable means that it performs similarly in different lighting and when the camera is shaking, as it's very important for a platform that moves around. So you can we can create a metric for the IOU for random rotations and with color jitter augmentations. It's my approach. So I pick a few different CNN and transformer-based models to fine-tune, and then from there, I can fine-tune them and find the best one and fine-tune that one further. So I picked Segformer B0, DeepLab V3 with a Resonant 50 backbone, and UPerNet with an MIT B0 backbone. The dataset that I'm using is the RELIS 3D dataset, so it's an off-road driving dataset with RGB images and LiDAR scans. I'm not using LiDAR scans, and it contains 19 classes plus a void class, and it already provides a train validation and test split. So my approach, the issue is that the dataset itself is very concentrated in 4 main classes: sky, grass, tree, and bush, and many of the other ones get drowned out. So what I decided to do is relabel it into four smaller classes plus a void class that are easily traversable, potentially difficult to traverse, obstacles and untraversable, sky, and the void class. So I augmented the data as well. So I added in random Gaussian blur, random crop, random horizontal flip, random rotations, color jitter, and image normalization. So my tunable parameters are the learning rate, number of epochs, batch size, cross entropy weights, the online hard example mining threshold, and Lovaas loss weight. So my results. As you can see here, the 3 models I picked performed pretty well overall, but the Segformer B0 model performed best. So I picked that. You can see my training loss over here on the left, and you can also see the confusion matrix. As you can see, the model does pretty well. It's pretty diagonal, so it doesn't confuse things very often. But I plotted the log scale one as well, just to be able to better understand what's going on. The results. You can see here one sample near the end of the validation run of the Segformer model. You can see it does pretty well. It misses some of the light poles at the end, but it does a pretty good job overall. And now comparing to the literature. So there's actually quite a few models that are out there, but the issue is that every model has decided to combine the classes in a different way. So for instance, Offseg, which is made by the makers of RELIS 3D, combine theirs differently as traversable, non-traversable, and obstacles, versus another one combine their classes differently as well. So we can compare the MIOUs, the mean intersection over unions, for each class. It doesn't really mean as much, aside because our classes are different, but you can kind of get an idea that the models that I decided to train do pretty well overall, as they're comparable to other state-of-the-art models. We can compare IOUs across classes for classes that we have in common. So for instance, I don't have high vegetation or grass classes, so I can't really compare those. But you can see there's traversable, obstacle, and sky, where our model actually does pretty well. It does better than most at the obstacle class, and it performs very well in the traversable class and almost like the other ones for the sky class. So we actually have a video here. You can see it running on the Great Outdoors dataset, which it has not been trained on. So that's a separate dataset. You can see it doing relatively well. On the left, you see the raw image. In the middle, you can see the segmentation, and on the right, you can see the overlaid model. Yeah, the average inference frames per second is around 87. And you can see that the model is not trained on the Go dataset at all, so this is the first time it's seen it. So different camera parameters, different everything, and it generalizes pretty well. So that's pretty interesting. Yeah, so in conclusion, we built a semantic segmentation model for off-road traversal terrain on the RELS 3D dataset. Classes include traversable, difficult to traverse, obstacle, non-traversable, and sky. And the model is based on segformer B0 with an MIOU of 0.855. And the model performs in line with the state of the art and generalizes pretty well. And here are my sources. Thank you very much.